naive Bayes classifier in artificial intelligence. So let's say you go to the eye hospital and like you have a data set here, and basically you want to get a new lens. So you can either get like no lens, you can get a soft lens, you can get a hard lens. Now these are all the data for each patient. So if the patient is young and he has a near vision and he has no tear production, then his lens type will be none. So if his age is middle age and he has a near vision and his tear production is yes, then his lens type will be soft. Okay, so this is basically a data set, and now you're going to use this data set to do some probability maths. Okay, and in this math I'm going to use Laplacian smoothing, and I'm just gonna show you that in a minute. Okay, so first off, let's say I want to find the probability that the lens type is soft given that the age is old, the vision is near, and the tear production is yes. Okay, so this will be probability of soft, age, vision, and tear divided by probability of age, vision, and tear. So let's find the top one first. So probability of soft, age, vision, and tear is, you're going to find the rows that are soft and you have to find the age. So age will be old, vision will be no, and tear will be yes. Vision will be near, not no. Okay, so soft and old. You have old here, it's soft, old here, hard. Okay, so one soft, and there are three softs here, so 1, 2, and 3, so 1 by 3. 1 by 3 times the vision is no and soft, so vision near, okay, near, none, near, soft, near, hard. So 1 by 3. Okay, so the number of soft times tear production is yes, so yes soft, yes hard. So 2 divided by the number of softs is 3, so 2 by 3 times the probability of soft. So basically find all the softs, so 1, 2, and 3, and there are 1, 2, 3, 4, 5, 6 rows, so 3 by 6, so 3 by 6. So you're just gonna like calculate this now. It should be around 1 by 27. Okay, so you're just gonna like repeat this process for the bottom one. So you're going to find the soft one, then you already found the soft one, so you're going to find the none, and you're going to find the hard. Okay, so let's do it. Probability of none, and age is old, vision is no, and tear production is yes. Okay, so if I wanted to use Laplacian smoothing for this one, instead of being 127, it would have been like 1 by 3, and Laplacian smoothing with a k equals 1 value, so 1 plus 1 divided by 3 plus 3, because there are 3 variables in age, so young, middle age, or old, so 3 variables, so 3 plus 3 times 1 by 3, so 1 plus 1 divided by 3 plus near and far, 2 variables, so 3 plus 2 times 2 by 3, so 2 plus 1 times no and yes, so 2 variables again, so 3 plus 2 times 3 by 6, 3 plus 1, and like there are 3 variables here, so 6 plus 3. Okay, so this should be somewhere around 8 by 225, which is basically 0.036. Now the probability of none. Now you're gonna find this one out. So none, age old, vision no, and tear production yes. So probability of none and old. None and old, it's basically 0. So like if I didn't use Laplacian smoothing, it would have been 0. But I'm just gonna like continue this thing. So 0 times probability of vision is none, vision is near. So this is like 1, vision near. So 1 by 1 times tear production yes. There's no tear production yes here. So this one's 0 as well. Now by using Laplacian smoothing, instead of getting a 0, what I'm gonna get is 0 plus 1 by 0 plus 3, because there are 3 variables in age, times 1 plus 1 divided by 1 plus 2, because there is near and far 2 variables, 1 plus 2 times tear production no yes, so like 2 variables, so 0 plus 1 divided by 0 plus 2. Okay, so this should be 0.11. Now normally it should be a lot lower than this, but since this data set just, well, it's not really a full data set, so you're not going to get like the best probability here. So none done, soft done. Let's find out hard. Okay, so probability of hard with age is old, vision is none, and tear production is yes. So hard and old soft, old hard. So this is 1. Oh, I forgot to like multiply the none one. So probability of none. So the probability of none is 1 divided by 6. Okay, so 1 by 6. So here will be like 1 plus 1 divided by 6 plus 3. So this should be 0.0244. Okay, so this thing's right. Okay, like this is a really small probability and it works. Okay, so let's get back to the hard one. So age old and hard, that's 1. So 1 out of 2, because there are 2 hard variables here. So 1 by 2. I'm just gonna do the Laplacian as well as this normal one. So 1 by 2 plus 1, because k is 1, and 2 is basically like 2 plus 3, because there are 3 variables here. For the vision one is near and hard. So near, none, near, soft, near, hard. So near hard is 1 by 2. So plus 1 plus 2 times tear production. Yes, soft, yes, hard. So 1 by 2, 1 plus 1, 2 plus 2 times probability of hard. So probability of hard is 1 and 2. So 2 by 6. 2 by 6 plus 1 plus 3. So this should be like 0.033. Okay, so after looking at all this data, you can see that the probability of it being soft is higher than 0.02 and 0.033. These two are very close together, but this thing's still higher. So basically, this patient will need a soft lens. Okay, so this is the answer.